Computer Science and Engineering from IIT Delhi, where he also received the Institute Silver Medal. He received his PhD degree in Electrical and Computer Science Engineering from Purdue University, USA. He served as a senior member of technical staff at AT&T Labs for some time before returning to India a few years back. So currently he is with IIT Ropar only. He has teaching experience for around more than 15 years and he has guided many students to perform remarkably well in several reputed technical contests such as IEEE VIP Cup, ACM ICPC, Microsoft Imagine Cup. So he's also holding a position of conference chair for the respected 10th International Conference on Computer Vision Image Processing. I don't know how many of you have submitted papers to this, one of the renowned conference in India. His research interest lies in image processing, computer vision, applied deep learning, machine learning, artificial intelligence, computational imaging, image forensics, security analytics, and assistive technologies. He has published several papers in international journals and conferences of international repute. So with this short introduction, now I would like to request Professor Puneet Gyal sir to kindly start the session.
I will talk later. Sorry. Hello everyone, am I audible?
Yes, sir. You are.
So I will just share my screen. It is asking what do you want to share? Optimize for text and images, optimize for motion and video. Any preference? Deepak ji, what to select here?
So you can select, I think you can just share the screen, sir, screen or application.
Yeah, it was saying give some AI it was using.
Okay.
So it is saying.
Yeah, it is
So,
visible.
yeah. So if there will be any chats that will be coming later, right?
Yeah. Participants can write in the chat box. Yeah.
Okay. So, dear all, thanks for joining this session, and I'm really very grateful to the Deepak and team for organizing this online FDP. I will try my best to share some insights which can help you in your professional and research career, sharing some insights. So, if any question, feel free to ask on the chat window, and I will not be able to see your chat while giving the talk. But if anything major, Deepak sir can WhatsApp me. And if you have any questions, feel free to ask later or now. So let me go. So there is an interesting topic, modern computer vision, and I'm glad that this privileged opportunity I have today. So source camera model identification using deep learning is something I will talk about. So before I begin, I would like to acknowledge my research students, my research collaborators, colleagues, reviewers, DSC Serve, which is ANRF now, and IT Ropar for giving me opportunities that has helped me contribute in my research, including this topic. So he has already explained about that, but just quickly, like I am also associated with Department of AI and Biomedical Engineering here, and I am interested to more make a progress towards making some societal application and real world impact. So this is a slide long time back, okay, from December 2021, and it will be nice to share with you this, my interest and my passion in the research in the image processing computer vision. So you see here, like image processing computer vision is more or less aligned. So you see the top search area. So it means the maximum number of papers contributed search in IEEE Explore in even December 2021 is image processing, and then AI. I come to December 2024. Again, still the maximum search area is image processing. Later, with time, IEEE has combined few things together. So now, today, I took the screenshot of the top searches, and it shows data science is the top one, and image processing is the second best. So it tells you, like, the world that we are dealing with, the topic, it's like we are in very right presence here, that this is a technology that is coming, many people are contributing to it, and data science, and which is like, these image processing, data science, they are all computer vision and extensions of that, to good extent, that aligns with it. Okay, so now, as we see here, the image processing, you can see, is a very touch topic. So it also gives a lot of scope, like, to make some active contributions in image processing and forensics. So I will just begin with a simple thing before I delve deeper, because it is very important to understand what I will be focusing. So for that, I am just brushing up. So this is a standard image classification problem. So 8, 9, 1, 9, 6, like the numbers are there, you have to tell what the content is, whether dog, car, apple. So I'm sure many of you are familiar with this image classification problem. Okay, and the problem becomes very challenging at times, because many objects are being there at different scale, and they are different background, poses are different, angle is different, and so on. So this is a very tough problem in general, but had been with the crack in the with the advancement deep learning, it was really amazing solutions were coming. So this data set, MNIST data set, and this is a very large scale data set, ImageNet, which sometime 2 years back, 1.5 years back, I calculated the citations are really very huge for these works, and that led to making a big difference. So what I want to emphasize here is one thing, that here the images are classified based on the content: fish, hen, bird, or dog, or these letters. They are based. The classification is happening based on the image content, and there are multiple types of classification, whether it's binary, multi-class, and multi-label classification. But in the problem that I will be touching upon, primarily we my team here, the research topic from them, my ex-PhD student and my postdoc collaborator, and Dr. Gaurav Sharma, who was the ex-editor in chief for ITP transactions on image processing. So we worked on this problem. So what we want to discuss here is these two images. If you see, what we want to identify, the problem we want to identify is that whether this image is taken from which camera model. Okay, so image content is same. I don't care about the image content now. So this classification is not at all based on content. That's the first main aspect, where the image forensic, particularly the problem that we are touching, is very different from other image classification problems. I will be having my input as an image, and I will be performing a classification, but the classification is independent of the it is not that much dependent upon the content. It is dependent upon the some noise, some fingerprints, writing style. As just like we have the our writing styles, different people have different signatures, writing style, and so on. So it is also like this, the camera fingerprints, we want to find out which camera this has come from. Why this problem is important? This has many reasons for it. We want to, many times a image gets leaked. Okay, we want to know where that image is leaked. So who was like, for example, some exam paper get leaked from one school. So we want to know who was the invigilator who probably had leaked it. So maybe if we can find out which camera model was taken to take the picture, so I can find out who was the faculty member who has taken the picture. That's a one just possibility I'm telling you in later. A blueprint of some defense lab of some there is a company working on really good new patentable technology or very secret thing. If their documentation get released, we can find out, like, who took the picture. Some defense lab, some another lab, their picture get leaked, who maybe the scientist, or who maybe the xyz person in that organization who leaked that image. So all these things are important. Other than that, there is one more reason for it. Sometimes some images won the best prize, best picture ever in the world of this year, this, that, like that. So there also you can make more authentic, that actually this was taken from this artist only or some other artist. So this problem has lot of significance for that regard in the image forensics, finding the source. There are many more extensions to it, which we'll see with the time in the presentation today. So I think the problem is clear to everybody. Like, I've given a picture, I want to find out which phone the image has been taken from. All right. So these are some data sets few years back when we compiled. These were the data sets which are the major data sets. So Dresden data set, Socrates, Fortune, and Spicum. Recently, more data sets have come. I will share about that. Let's see. We are working on review paper here. So, uh, so I will just want to give you a clue that we have, made a compilation of lot of new data sets also that are been happening in this domain. Okay. Yeah. So maybe little down. Yeah. So you see here, these are the lot of new data sets that have come, new data sets that have come. So there are a lot of, new data sets that have been added. So this is just still working on the manuscript on that. So would like to share the same things to you. I think the problem is clear to everybody. So these are very different problem, but please understand compared to regular image classification problems. So, and we'll see some insights to it. Okay. So now these are the some different methods that have worked upon it, how they work upon it, and this is also the where the difference happen when we work on the image forensics. In image forensics, the noise is important to me. In regular deep learning, you actually resize the image. If you resize the image, then you lose lot of fingerprints, lot of important factors that are important for you for the forensic perspective. So unlike other methods, other image classification problems, where we easily use Desnet and many other tools easily, we resize. But here we cannot choose to resize. We may lose a lot of information. So we extract different patches from the images. So these are the different methods which extract the different number of patches, and the size of patches could be 64 by 64 or even 32 by 32, or it could be 256 by 256 also. Here you can see that. So we will extract some meaningful patches. If some area of the image is very saturated or very dark, we just ignore, we intend to ignore those kinds of patches at times. Okay. So this is a generic pipeline for the source camera model identification. We first extract the patches, we do some pre-processing, different types of pre-processings are there. Okay. And then we will also see what we have done. Then we perform the classification, and then we perform the majority voting. And after majority voting, what is the majority voting? That's another interesting thing. So from one image we got multiple patches. From one image we got multiple patches. Now some patches are saying that this is, Nikon D200. Some patches are saying this is OnePlus or some other camera. So we want to like to see that if there are 100 patches taken from an image, and majority, more than 50% of the patches, or let's say most of the patches are saying a particular kind of a camera model, then we choose that particular camera model as the answer. So there are therefore not two different evaluation metrics come into play: patch level accuracy and image level accuracy. Of course, higher the patch level accuracy, the tendency is there the image level accuracy will be also best. So, but our ultimate goal is image level accuracy. These are some existing, these are earlier recent works only, that they perform some homogeneous patch selection and extraction, then patch classifications, and majority voting, and then we focus on the patch classification. This is just one work, as you mentioned in the citation. So this is the deep learning network that they followed in their work. So this is the brief summary of most of the recent works, and we provide it in very stage-wise manner, that whether they perform the, like, number of patches they extract, what is the input size, and the patch size, and whether they perform any pre-processing or not, and the classifier is one branch or multiple branch, and which are the data sets they have investigated their methods and compared with, and the evaluation metrics that they perform it. So you people may be performing the research in a different direction. So this I'm just sharing a research insight. If you have yourself or your students prepare the summary of the different works in very summarized manner, it helps you also to comprehend many things. This gives you much better insights at times, and it's easy for your reviewer or the expert respected reviewer of your journal or conference. Okay, now coming to the work that we did in this particular domain, how we come up with some novel method. So it's a very, like, strategy that we followed, very interesting strategy we followed. Like in cricket team or some other team or any other team, we would like to have the experience from the young people and the and also experience of the we want like to have the experienced person and also would like to have the young persons. So it gives you quite a good dynamic. Similarly here, we combined that the patches that are extracted, okay, we straight away send them to the ResNet deep learning model, okay, and we let the image uh, be the governing factor itself, and we rely on the deep learning knowledge that they will be able to identify, extract relevant features, discriminating features for the different camera model. At the same time, we provided a filtered output. Okay, we perform the high pass filtering, okay, because we want to enhance the noise, and that noise will serve kind of a better discriminating feature for the image forensic perspective to discriminate different camera models. So we combine both of them. Let the this because you know the power of ResNet in general, and the similar deep learning models, they are trained on the actual image content. So they know, like, for the they tune themselves. If we give them a lot of data, they are willing to get tuned, like they generally get tuned for performing better, and they be able to extract the relevant features from the image. So we just combine both of them, and then of course we pass it to the fully connected layer to decide after the major voting which is the predicted camera model. So this prediction is done for each of the patch of so many patches that are extracted. Each of the patch gets classified into one camera model, and finally we decide which is the final predicted camera model based on the majority voting. So now, what is the high pass filtering method that we used? So there also, what we did, we have seen one of the key application in the image forensics analysis. So we led to the literature in that domain. We found there are three SRM. There are a couple of SRM filters. They call it SRM filters, which are very much used. But we were dealing with the RGB inputs, and we wanted to use the ResNet as a backbone only, which takes three channel input. So we just choose three channel output here coming out from the filters, high pass filters. So we choose these three filters, F1, F2, F3, which are kind of a SRM filters in the literature. They were proven to be performing really nice for analysis work. We wanted to use it for investigate this their usage also for this camera model identification. So you can see here that these are two different images from two different camera models, and you can see here the same filter output. Okay, the kind of a noise it is inferring from this particular images which are taken from this particular camera, and the noise which has been inferred from this particular camera model. There is a significant difference in the noise patterns. Okay, so we believe that if we train it very huge with these filter outputs in our model, the model will become more smarter, and that's what happened. Okay, so when we perform like this is our final thing that we mentioned, that we perform the high pass filtering, and we also give the input image patch by itself, and then these are the dual branch network that I mentioned. And we see, if we want a good paper, we must need to have a good mathematics also. So they we summarize our patch level accuracy and image level accuracy in the mathematical form. Alongside that, we also proposed a new metric which gives little slightly more insight. It says that average percentage of majority class votes for correctly estimated images. For example, if let's say consider two different images and both the images led to 100 patches. In one case, one model is getting decided because the number of patches, which are majority, of course, is 60. In another case, it is 80. So we will say that other method is still better because image level accuracy wise, both methods are okay. But one model is more confident. It is number of majority class votes for correctly estimated images is higher from that particular model. So we use this. It is somewhat related to PLA, but not exactly. Okay, yeah. So this is an interesting and important slide. I would request my kind audience to please give attention to it. So this is some mathematical. This is okay. Left side. This is just telling how we extract the quality patches. We just relied on the literature, and we choose one of the methods in the from the literature to identify our quality patch extraction. So we extract 256 patches of each size 64 by 64. Okay, but the important thing to observe is this right side graphs. Okay, one of my friend, like once he presented here, he also explained and helped in our research group, giving us a wonderful insight that if you want a really good publication, you must investigate your results experimentally as much as possible, or to say the word that they use is bombard themselves with results. So we also made a very extensive comparison with different methods, which I will highlight now. Okay, so what we did, we compared on two different metrics. PLA, these four curves are for patch level accuracy, and these four curves are for image level accuracy. Why four curves? Because we are working on four different data sets: Dresden, Socrates, Fordsham, and SP Cup. Dresden, Socrates, Fordsham, and SP Cup. So we compared on four different data sets using two different metrics. And what is these curves showing? Okay, these curves are interesting. So we have 7 8 different methods I compared my method with. I am comparing my single method with 6 different methods. And how I am comparing my single method, my proposed method, our proposed method with these 6 different methods. So as I mentioned earlier, in camera model identification we had two things. One is patch level aspect. Okay, we are extracting the patches and then applying a particular classification method. So somebody may say that okay, your method actually is not that good, your patch extraction strategy was really good. Okay, or they may say the previous method was actually not that bad, it's just that their patch extraction strategy was not that good. So they may say in this and that term, something like that. So what we did, we know for each of these published works their patch extraction strategy, and we have our also our proposed patch extraction strategy with a slight modification that we are using 256 patches. Earlier work were using lesser than that. So what we said, we will compare it with the naive method, where this ping thing, where the patch extraction strategy is there, and also the classification method is also theirs. Then we have this method, okay, where patch extraction strategy is ours and the method is that cell, that other method. Then we have this yellow thing where we say we have our method and their patch extraction strategy, patch selection strategy, what we are calling it. And of course the blue is when we have our patch selection strategy and our proposed method. So you can see here, our method combined with their past selection strategy also gives a very very good accuracy. And of course the best results are coming even if you say image level terms, or if you see the past selection terms, best results are coming when the method when the past selection strategy and the classification method is both the proposed method that time. So we did extensive comparison. It's not that just we compared with other method, but when we are comparing with other method, we did compare. This is the first bar graph here and the last one. Okay, for any of these methods, but we also compare in terms of their both aspects, past action strategy and also their method. So in both the cases, we were having the win-win by our proposed method. So these are some results, and you can see we compared with all these different methods on 4 different data sets, and on average also the method accuracy of the patch level wise, it was coming 99 99%, 90, and for the image level also 98 99, like that we were performing really very good. So is the problem solved? Actually not. So we'll see that part why it is not actually solved. Before jumping into that, here we are showing the ablation study results. So you can see here, when we are taking less number of patches, okay, when we are taking the less number of patches, then the performance is less, but as we increase the number of patches, then the performance is increasing. So we are telling that what is this result showing? These results are showing if we just take the RGB branch or the noise branch, the filtered output. So this is the dual branch. So in case of when we combine these two dual branch, our performance was really high. This blue curve in terms of patch level accuracy, image level accuracy, or the proposed metric APMVC, it was really the high performing compared to the other aspects. So single branch was not performing that well compared to the dual branch. And even in single branch, we can see ultimately noise branch performs better than the simple input image. Okay. One more thing I had not expressed. This Chen et al. Method, it does not perform any patch extraction. They just do the resizing of the image. And we see that impact later. Okay. And here we also perform the ablation study comparing different backbones. We found that Resonate 50 was serving as the best backbone. So we choose the Resonate 50. So we had a good decisions, that we have valid reasons for our decision that we took in the proposed model. And we also performed the cross data set experiment. We took up the camera models which are common in two different data sets. We trained on one data set, tested on the other. Again, we see that performance is best for the proposed method, but of course, it is not as 90%. So there is intrinsic, inherently few things are there. Okay, but in terms of image level accuracy, still we are performing 85%. Of course, we would like to observe, we would like to work to further improve. As we can see in the cross data set settings, the results are not really above 90%, and so yeah. Now coming to the real world scenario. In real world, whenever any image gets leaked to any antisocial element, the image is not actually the real, original image. How many of you, I'm not sure, do you send the original image to any other person when you're sharing something secret or something very quick? No, we share the image using some social media to other person. We do not send them as an email or attachment, or even in WhatsApp we also do not send them as attached as a file. We send them as an image. Then what does WhatsApp do or Facebook do? They perform certain their own proprietary compression algorithms to benefit, to maximally optimize the network bandwidth and so on. So they send the compressed version. So the image that is received at the receiver or later been used for investigation, that image may not be the original image. Okay, that image may be some social media processed image. So actually we must perform the this this source camera model identification from this source, this social media processed images. So we fortunately found certain data sets. Okay, this Forsham data sets of five different social media that they have considered. There are 3,851 images original, but they created they had used five different platforms. So they got the five different sets of this particular set of images. And there is a vision data set also, which but which also send the social media process images, but they use only two different social media platforms. Okay, so when we compare it with this, what we did was we have now five times or six times the data for training. We just trained them. We just trained them, and we found the performance, how it performing. We observe, if you see here, the performance is significantly low for all the methods in general. Many methods perform really poorly. Okay, of course, our method also had the performance decreased. For Facebook images, it was just around 71%. For WhatsApp, 85%, 79%, 87%, and so on. For different methods, the different results were there, but we can see the performance decrease, and it was expected. But this is the problem that we would like to explore and challenge. For the original images, it is coming 99. But observe how these results are different from earlier results. Earlier, you trained on original images, you tested on original images. Here, you trained on whole set of images, like six times the data set for training. Okay, and then you're testing, and your data set for testing also is different. And you see the observation. Okay, now it comes to us an interesting problem, why we want to have the same source camera model identification model for all the platforms. Can I not have one camera model identification method for Facebook, for WhatsApp differently, for Instagram differently, for Telegram differently, for Twitter itself differently? Because all these social media, they are having their own proprietary algorithms for compressing the image. Combining them all together in one model, it may not be able to capture best the fingerprint camera model fingerprints. So why not let's them separate them all together? Okay, we will, if we know that the image leak is on for Facebook, we will just use the Facebook camera model identification. Similarly for other social media platforms. So we just did that in our work. Okay, so we also made this problem as an automated problem. This is just showing another work which we presented in a conference in Malaysia in their special sessions there. So this is the work that given an image, can I find out, given a compressed image, can I find out whether image is an outcome of WhatsApp or Facebook or Twitter or something like that? Here we use a lot of filters. This is just showing the, as I was telling you, the SRM filters. Here we use all the 30 SRM filters, and we found the results were interesting. We are able to identify this social media with very good accuracy on these two different data sets they are showing. We were correct in our method by 100% accuracy. So this method is for recognizing the source social network identification. Okay, we are just identifying the source social network. Okay, right now we have not still performed the camera model identification. So we use the camera model identification. These are the results of camera model identification. So interesting results. So we see here that if we use a Facebook camera model identification model for Facebook processed images, our accuracy for image level is 72.66, while otherwise it was 70.99. Similarly, here also we observe that for the WhatsApp it is 86.84 versus 85.52, 81.73 versus 78.92, 88.76 versus 87.22, 92.97 versus 92.46. So, and observe that the number of training images in this model is 6 times the number of training images which went to this camera model, social media specific camera model identification method. Here only X number of training images were used, here 6 times X because it's an augmented data set. So this is getting benefited because of extensive data set, and but still it is not performing that well compared to a specialized network which is only on 1/6 of the total images used in this particular generic model. So this was an interesting result in that regard. Okay, so this is another data set that we prepared and showing the results of that. Okay, this work is in progress. So here what we did, because we found that existing camera models data set were not solving this problem. What we did was we took the help of our students. Of course, we had two different sets of images we trained. One is a completely random images any person will take from his camera phone. Okay, any random sort of images, there is no constraint, any images that he can take. Of course, for the privacy reasons we were not taking the facial images or facial or person identifiable images. Some other images only we were taking. Okay, and then we took those images, 150 plus images from different camera models, but we also took the similar looking images. So when the image classification network, which is to be trained to differentiate between the image source, it will not get confused with the image source. So image source is exactly same, only difference is camera model that is used. So we took this similar set is that we have the images of the same kinds of objects. These are the example been shown. There are the 4 different images taken from 4 different camera models. You can see here. This is the IT Roped very strategically built structures here. Okay, and so on. So almost the image content is same, but the camera model is differing. And we observe here also that accuracy is so good when we train on similar set and test on similar test, we are getting 98% accuracy. Okay, and even if it was to be trained on random images and tested on this, accuracy was just 80%. But if we train again on similar images and test on random, our accuracy is around 88% and so on. Okay, so the another, I hope any questions so far in this regard. Okay, all right. So I will proceed forward. The another work that we are doing on image forensics, like a very simple thing, like what kind of a forensic manipulation image change that has been done in the image. So this is the architecture we proposed in this work. Okay, it's a complicated architecture. We again highlight the noise patterns. So for that we perform this model pre-processing, and then we feed to the network. Okay, more details are there in the literature, but coming to the storyline further. So this is the pre-processing I was telling you that we were performing, because pre-processing helps yield better results to for the given standard problem. What again we did in terms of experimentation, we compared 10 different image processing operations: JPEG compression, Gaussian blurring, adaptive white Gaussian noise, resampling, median filtering, contrast enhancement, JPEG anti-forensics, I'm not sure if all of you are familiar. I think for some of you this term may be new, because when I entered this research domain, it was also new to me also, that there is JPEG anti-forensics also, image processing operations. Okay, and then medial filtering anti-forensics, contrast enhancement anti-forensics. What are these anti-forensics? These anti-forensics algorithms are that given a JPEG image, they will apply certain processing operations so that nobody can tell whether the image is actually JPEG or non-JPEG. Like that, they try to perform that with best of their ability, of course. And we use different parameters to in our training set. So we pick up few training data, and we have random number, this random parameters here, different parameters here. We generated a huge data set. Okay, and we want to find out that what we want to find out, that what is the image editing operation performed on the input image. Is the input image original, or image has coming after being performed certain operation in this regard. And these are some results as of that date. So this, we compared with other methods, we see that our performance, our model that I showed you just few minutes back, that was giving the better results. Overall average 97% accuracy compared to the other models. In terms of dozen, in terms of Bose base and dozen, there are two different data sets here. So we compared on them again. In that also, our overall average accuracy is 97.5%. Okay, and these are the results on cross data set setting. Okay, don't go to the first row, please. This original is, of course, very very poor. Okay, original results are just 0.17 accuracy, and it should be right. It should be right. Okay, why, I will explain it soon. But overall average of other methods, if we take, okay, their results are coming 99, 99, 95, 92, 92, 89, 89. But because of that, the performance dipped. Overall it is really good. Why this is different? Of course it is to be different, because this model is trained to identify whether the image is actually taken by the Bose based litid cameras. But when the recent data set is coming, the camera model is different, camera devices are different, so it will not claim them as the original images. Okay, so these models actually fall apart because these are from cross dataset settings. So it should be obviously that the original images should not be classified as original when we are using the cross dataset setting, or to say we will not be able to identify that clearly. Okay, so this is the similar work which was extended later. And we also explored the image explanation aspects also in the forensics. So we explored that as we know that there are three different types of explanation methods: interpretation types, model specificity, and explanation scopes. But and one of the famous one is GradCam. But please observe here, the GradCam works on the image content. It highlights the feature, and we can see, okay, dog is being identified as a dog because the model is also focusing on the dog related features. But in case of image forensics, the kind of problems that we are dealing with, there is no content that we need to focus on. Will be getting the content, of course. There is no image. If the content is not really relevant, that image is not relevant. But the content is not important for the camera model and identification aspect of view. So these models, GradCam and other things, will not be able to perform that well. So we did certain mathematical or statistical measure based comparison, statistical measure based some predictions and insights. But this was been done only for the binary classification problem in a way. Okay, so given an image, we extract certain features from the last convolution layer. We perform the mean along the channel axis, then reshape into 1D vector, generate the histogram, and we calculate from this histogram different frequency values, like mean, median, and skew, and other things like that. We observe that these are the data set for image manipulation operation, and we see we took these statistical measures: skewness, median, and kurtosis. And this green is that those JPEG images classified as JPEG images, JPEG images classified as OR, original, and original images classified as original. Here this is related to Gaussian blurring, here it is related to median filtering. So you can see here that images are, there is a good demarcation of the JPEG and original images, and so on. But there is some mix up also. But overall, our model was able to make the discrimination quite good in terms of these aspects. Okay, there is another interesting work we had done earlier. This was published in 5% Impact Factor Journal. That can we use AI to protect against AI? Okay, what we wanted to do was that given an image, certain attributes of the image, okay, we want to suppress, but overall image to be remaining the same. For example, when you upload an image on some social media, you share it for your friends and for other people, relatives and other people to follow up and enjoy, like whatever the thing that you're sharing. Okay, you don't want the bots to make some profiling out of that and show you some ads. For example, a bald person regularly shown some oil ads, it may not be that good looking all the time. So we want to change the image in such a manner that the perception of the human being will not change. Both the images look same, more or less, but in this image I am able to decode that whether the person is bald or not, but in this image I am not able to decode whether the person is bald or not. So we perform that kind of operations also. Here what we use the grad cam tells us that which are the more prominent pixels that the image is focusing on to get a result. We then identify those particular regions in the model itself, and then we basically decode it and add some noise there, slightly some noise there, and those are the most active regions. When some slight noise is added, overall image perception remains the same, but the deep learning model becomes uh, unrobust. It doesn't give that good accuracy. So you can see here that earlier the model was performing really well, but after our method being involved, the baldness accuracy decreased significantly. If we don't add any noise, it was giving accuracy up to around 78%, but if we add little noise and so on, the accuracy dropped significantly. Now coming to interesting work that we are doing here or nowadays. So far the data sets that I have shown you, even the data set that I have shown you in this, they are not a document data sets. Okay. Ultimately, we want to find out the leakage of the document images. Yeah. Yeah. So we want to find out the difference, source camera model identification. Lot of the times we are dealing with the document images, not the real world images. And document images, when you take a document photo, you know how accurate you are. You take it very close, and the images are generally black and white. The document images are of different states, altogether very different compared to generic scene images. So we are preparing the data set. So we are prepared in different positions from different devices. So we choose 35 different devices, and we have some exam papers from different parts of the country, and we prepared this data set. Right now, my team is working making the social media process version of this data set. So you can see the kind of models that we picked up, and there are some exam papers. Sometimes just English, sometimes English in the mix, like that. And these are my ex-MTech students shown in the lab that how carefully they were conducting the experiments and preparing the data set. Now, any discussion on image forensics, I think, will not complete unless we have the deep fake. So I also included that partly here. So I think deepfake doesn't need any introduction. Preparing the deepfake videos is now very much. There's a lot of news buzzwords regarding that. So this is a thing from the Pi Labs. A very interesting slide, like how we have moved from postcards to shopping stores, social media, from postcard to social media, from shopping store to e-commerce, from inline letters to messaging, and from finance to fintech. Okay, so these things have really enhanced the efficiency, but there are a lot of threats, and deepfake is targeting this threat significantly, whether in finance sector, commerce, social media, and so on. So just last year, 200 crore scam, fake video call, digital arrest we hear nowadays. Okay, even some scientists are falling victims. There is some chemical expert. His deepfake video has been used in other place he was not aware of earlier to sell some prescribed certain medicines. Okay, we have seen all these deepfake videos related to our celebrities and so on. There's just some screenshots of those news. Okay, Professor Mayank and Professor Richa in IT Jodhpur. They are really doing very advanced work in this particular domain. So this is just a video link, and if you people wish to explore more, you can go to that video and see his views. So, but deepfake is a challenge. I showed that part, but deepfake has lots of benefits as well also. Okay, so let's see. Any before I jump into it, can somebody tell me what are some benefits of deepfakes? Let's see in the chat any benefits from the deepfakes you feel. Anyone in the audience?
Yeah, participants, if you're having any queries, please write it
No,
in the
no.
chat box.
Just I'm just asking what they feel to make it little interactive. In the last, we are just in the last only. So in the deepfakes, any benefit do you see of the deepfake? Is a threat. We have seen that. I have shown you it's a big threat. But any benefits? Anybody? What are the benefits of deepfakes? Oh, great. So, scientists, Aditi, you have mentioned very well. As a scientist, we need to prepare big data sets. It can help us generate big data sets. Anything else? Okay. All right. So, I think I will jump into the discussion further next. So, you see here some of the benefits in entertainment. So, we can create very funny videos just for fun and other things like that. Very different ideas which are very difficult to require lots of cost. Marketing and advertising for rightful good purposes, the deepfake videos can be prepared. Okay, for education, the deepfake videos can be prepared. For example, a very good scientist, okay, he's explaining the different things in the different languages or animating it in a different manner. Okay, that makes it a different that makes it really live. Even if I'm not physically present here, let's say, can a deepfake of Puneet Goyal can that give a lecture? Okay, so in that regard, in journalism, media, social media interactions, when two people are interacting, the bandwidth is very slow. They're facing certain challenges. The deepfake can really add really nice, like Instagram filters that we have seen. So deepfake can really enhance your performance to each other in a way. Okay. So political and social awareness camps in the regional languages, okay, by regional celebrities and many other things can be done. Uninterrupted video live interaction. I told you low bandwidth issue, so sending the original data is very tough, but generating through the app deepfake of the person as if that person is live interacting to get the more engagement. That makes it really nice. Uh, Virtual reality immersive experiences, some the kind of a different worlds that exist, which may not be, which are just hypothetical speculative ideas or different countries. One can experience because of deepfake. Then training for the defense personnel, and rather than medical people operating on the real patient, they can be first trained. Okay, provide treatments using deepfake. They can exercise different things. We also see that many times it's not fully deepfake, I would say, but still part of it. Like what which specs will fit best to me? How will I look like with the different specs? How will I look like I wear different dress or different uh, uh, hairstylists and other things like that, they also use it. So deepfake helps, easy to scale, time saving, and it's a low cost video generation. So many new artistic creative designers, they can use it to advance many of these different applications like that. So deepfake has its own merit, from entertainment to education, from marketing to medical treatments, but as we know, it has its disadvantage also. So the challenges that I feel is that culturally and psychologically we trust videos, and deepfake videos can really create a lot of chaos. But deepfake detection is really tough because when the images are coming through social media, they have gone through compression. they get large scale distributed in few seconds. And if defect detectors are predicting every video to be false positive, okay, then even original defect videos, if they are not getting detected, it will become difficult for us. And uh, the defect generating algorithms, the defect generators can also use the defect detectors to improve themselves further. And lastly, which I will appeal here to my audience, that it's a lack of awareness that we can address. Whether we believe it or not, deepfake videos is something we will be facing in a local region, in our community, with the people around us. Some one or the another, we may get targeted because of the deepfake as the technology gets more mature and other thing like that. Because because as I told you, culturally and psychologically we trust videos, so there is tendency that large scale challenge may come because of deepfake. So I just suggest that when we use deepfake, when we see any video which we are receiving from anywhere, perform fact checking and see whether the source is trustable or not. And we need to conduct awareness campaigns and be prepared for the we have to be really prepared for the deepfake videos. We shall not take any extreme action ever because of the something that been absolutely wrongly distributed or some financial fraud happening because of the deepfake. Okay. And I think Deepak is things for me. So I'm just sharing again that we are organizing the 10th international conference on computer vision and image processing. So for this audience, I think I must share this, that this opportunity, there are must lot of great speakers coming. You can explore more on the website. It is a great networking opportunity and enhance your research. And paper submission has already been done, so I cannot request you to paper submit the paper, but you can still participate, appear, come for the conference. If you're facing some financial challenge which is not making you easy for you to face, we will be happy to help you out to provide certain grants for the needy people if required. But reach out and participate your level best if possible for you during these dates at IT Ropert. So on behalf of IT Ropert and CVIP, we look forward to welcoming you. Any questions or comments? Were my slide visible, Deepak? Last few slides?
Yes, yes, sir. It was visible, sir.
Only now I disabled. Yeah. Okay.
Yeah. Yeah, participants, if you are having any queries, you can write it. You can write them in the chat box.
By the Deepak sir, congratulations for your IEEE transaction paper.
Thank you. Thank you so much, sir.
I saw on LinkedIn just recently. So
Thank you so much.
great. It's not easy, it's tough. So
Yes, thank you. So, any queries, participants? Maybe they are typing. This is a very important topic, even for the because forensic is a very important thing which has direct applications, right?
it is a
So
lot of scope for research also, like because unlike content based image classification in forensics, it is not content based. So there is a lot of scope, as we identified that in real world scenarios, accuracy, no algorithm was, even ours was no one close to more than 86%. It was best 85% like that. So in real world scenarios, there is still scope for finding a problem in classification, which is not giving accuracy more than 90% is very tough in today's time, I would say. It's tough.
yeah, so there is one query in the chat box.
Yeah, Pradeep, any modification can be said in backbone network. Yes, it is possible. It can be explored. Okay, something more better, which works better for the social media processed images. The work is still to be investigated and experimented. So by giving insight as such, because these are as a deep learning is very high dimensional data that we deal with, because in a very high dimensional feature space we are in. So it is difficult. And when we are working with the forensics, okay, then the problem become much more tougher, because there the content which was a good insight provoking for us, that also is not there. How you interpret noise, you and get insights, but it's more experimentally driven. But there are more interesting problems I can tell you in this domain which we are working on. As I told you, first of all, we are working on document images. Secondly, the interesting work that can be done is or towards a federated learning or incremental learning. In the real world, can we prepare the data set by taking the phones? Some, let's say, for example, I'm sure, or many of these are faculty members, right? Right, Deepak ji?
Yes,
So if
yes, yes,
something, some leakage happens in your institute by XYZ faculty, will you like the investigative agencies to take all your phones? Will you like investigative agencies to take all phones of all faculty members? What do you say, Pradeep ji and other members? Will you like it? Yes or no? No, exactly. We will not like it. So, data set will require taking the phones, taking pictures from everybody phone, this, that. But that is not possible. So, can we do perform better when that new model of the phone is not available with us, or whether only very few? You can give it for 5-10 minutes for that investigative agency to take photo if required. Okay, but you cannot hand over for him to her to take pictures for one day. Okay, so there are many other aspects like that, like how we can perform the better with the new model when the new phones have come into that. Phone available is not available for much. Can we try something with the federated learning? Okay, the model is not, we are not sharing our phone with the investigative agency. Investigative agency is sharing some deep learning method with us, which we can say run on our own model to train on the different images. Okay, then we'll not mind that much comparatively to sharing the phones. There are many directions like that. Yeah, it's a challenge. It's a good question that many people have same model. So actually there are three different things that has been done in this domain. One is make identification, whether it's iPhone or OnePlus or Samsung, like that. And then model. So one is make, another is model. Okay, and then third thing is device. So we have shown that some literatures have shown that device level identification can also be performed by deep learning, but challenge is data set. How will I prepare the device level data set? It means that I have to have multiple devices per camera model, and those people be willing to give their phones. We do not have that much fund to purchase. Let's say if I want to make 4 devices per camera model, I do not have funds to purchase 140 phones or get 140 people to share their phones for significant amount of time for us to prepare the data set. So that's, I think, the challenge in long scale everywhere. So that's why their work is mostly on camera model, not on camera device, but that can be done. Yeah, but we'll still, the people having all the phones, these 35 phones also from students only, Pradeep ji. But getting 4 different camera models, four different devices of the same camera model, and the student giving it for one day for us to take 300-400 images is not easy in general, difficult. But it can be done. If somebody want to prepare, they are more than welcome to do.
yeah. So
Yeah, I think no
yeah,
more questions.
yeah. There are no more questions, sir. So I, on behalf of Department of Computer Science Engineering and E&ICT Academy at MNIT Jaipur, would like to thank you very much, sir,
Thank you,
for
Deepak ji.
accepting our request and taking out some time from your busy schedule. I know you are very, very busy,
No, no,
and
it's
organizing such a big conference is really a headache. But you could able to manage, and you could able to give us 1 hour of time from your busy schedule.
no, it's
So we are really thankful to you, sir.
thank you. How many audience are there? Like how many participants you have?
Currently, we are having, I think it was more than 60, currently 57, sir.
Around
We are having.
57. Oh, from different parts of country, is it?
Yeah, yeah, yes, sir. Different parts of the country, sir.
Okay.
Although 100, more than 100 have registered, so probably because of some, timing problems and all, maybe their class schedules and all, so they could not able to join us all the time. but at least more than 60 participants are joining all the time, sir.
Okay. I've shared my email ID here. So if anybody
Yeah.
wish to contact me, they can reach me on this. Okay. We'll be love to hear from you if anything I can be of help to anybody. Okay. And that's it. Thank you, Deepak
Yeah.
ji. And
Thank you.
all
Thank
of
you
you
so much,
once
sir.
again are welcome to join at IT Roper during CVIP. Okay. Thank you.
Thank you, sir. Thank you so much. Yeah. So participants will be having another session. I mean the final session on object detection, right, which is one of the most important applications, right, which you've been seeing. Its applications you've been watching since last 7-8 days. What is object detection? You have seen. You have also understood what is object detection, but today we will get to learn about how to design the deep learning models or how to solve this object detection problem, right? So this session will be delivered by Dr. Aditya Nigam from IIT Mandi, right? So he'll be joining soon. Please wait. Yes, yes, Pradeep ji, है ना? 5 मिनट तो ब्रेक हो ही जाता है. I think we'll start at 7:30, so there's a 5-minute break.